Read the question carefully. So we have the formula here, PV equals KT, and we are asked to find derivative of P with respect to time T. So let me write down P from this formula. So PV equals KT, and K value is fixed, which is 1. So that is same as PV equals 1T, just T. And all of these are functions because they are changing. So that implies P equals what? P equals T over V. And we are asked to find dP over dt. So let me write over here, P depends on two things, temperature T and volume V. So this is a function of two variables. I'm trying to write the chain rule. If you know the formula, then you don't have to make this diagram. Depends on T and V. So when we do this way, we need to find partial with respect to T and find partial of this with respect to V, partial derivative. And this temperature depends on time T, so we just find regular derivative because only one variable, that's T prime. And V also depends on time T, so regular derivative V prime. So the rate of change dP over dt, I'm just writing formula here, dP over dt is partial of P with respect to T times, this is regular derivative dt over dt, plus this way V partial, so partial of P with respect to V times V prime, is the regular derivative dV over dt. And if we read this question carefully, what is given? Let's see. dV over dt is 3, so this is given 3, and dt over dt is 0.8, so this is 0.8. Okay, now we need to determine T partial of P and V partial of P, so which is found using this formula. So let's find partial derivative with respect to temperature T. So partial of P with respect to temperature T is, now T is a function, V is constant, so 1 over V constant, and derivative of T is just 1, with respect to T is just 1, so 1 over V. Okay, and we need to find V partial derivative of P, so partial of P with respect to V. Now V is a function, T is constant, so T times 1 over V, so T survives, times 1 over V, and derivative of 1 over V is like 1 over x, and we know the derivative of 1 over x is negative 1 over x squared, so that's negative 1 over V squared, so that is pretty much negative T over V squared. So if we come here now we can work on this. So dP over dt, partial of P with respect to T is 1 over V times 0.8 plus this is negative T over V squared times this is 3, and we need to find, we have these values. Okay, under this condition we are finding dP over dt, which is 1 over V is 20 times 0.8 is negative positive negative, T is 300 over V squared. Okay, V is 20, so 20 squared, 400 times 3. Now use your calculator and you get the final answer. So minus 2.21. How about the units now? Okay, this is pressure with respect to time, so something per minute, because the time is given in terms of minutes, so bottom is just per minute. And how about P? If we go here, we can find the units. Okay, P has units. T is in Kelvin over volume is centimeter cube. Okay, so Kelvin per centimeter cube per minute. Okay, this is time per minute and this is pressure final.